All right, welcome back. Just gonna go ahead and get right into it here. Try to keep these short. So in the last video, we set up a bunch of these models here and a little bit on the manager. I think I've decided some of the Pydantic implementations that I used were kind of sporadic through a couple different versions of Pydantic. But I think I'm actually just going to focus on the V2. So you check out Pydantic. They're on 2.10 right now, because there's some pretty cool features that are available to us if we use at least 2.10. So if we consider a connection model here, one thing that we shouldn't be able to do, for one, it wouldn't make any sense, and for two, it's just gonna break shit. Is we shouldn't be able to redefine any of the fields that are created on this connection model. So you can imagine if we go to get an initial connection from a WebSocket and then later change the client ID, that's just going to break a lot of things. So that's something that we should disallow, and Pydantic offers a way to do that. So we can, at the connection model here. So one of the things that we can do to start off is we can use this other parameter here on the config dict, which is frozen. It's going to be equal to true, which means when this object is created, the fields, so the client ID and the WebSocket, are going to be disallowed to change. So they're basically going to be, the fields themselves are basically going to be immutable, which will disallow things like what I just showed you here with this redefining the client ID field. And we can check that out here in a moment once we implement some of these other models. Another thing is the UUID type is actually also available from Pydantic. So if we go and import that, we can import UUID, and we are going to use that UUID and get rid of this one. So we got that here, and that should be from Pydantic. I believe it is. Oh, sorry, it's UUID4. That's the one that we want. So we're going to type this as UUID4. This is going to be UUID4. Same here. One of the other neat things that I saw is there is a type definition presented by Pydantic, and it is called instance of. So we can import that as well, and we can actually use that to ensure that the type of these fields are an instance of, some kind of object. So we can do that here by specifying WebSocket as an instance of generic type. And that will essentially do away with some of these field validators and make the code a little bit cleaner, which is always nice. So if we move on to the connection response payload here, we can do the client ID is going to be an instance of this UUID4 type. And then we can completely omit this field validator just with that instance of. And one of the other things, this connection response payload should also never be mutated. And I can't think of a single logical reason why you would ever need to mutate most of these models. So you'll see that we'll be using that frozen equals true parameter a lot here, but it just wouldn't really make sense. Once you create this connection response payload, what would be the point of reusing it and resetting a field? So you might as well just define the frozen attribute or frozen parameter as true. So we'll do model config is config dict, and we will I guess another thing we could talk about too is, so with PEP8 and syntax standardization in Python, obviously we use snake case a lot, screaming snake case and stuff, and other APIs and other languages, they expect their syntax to be different. So for example, in JSON, I believe the standard is I believe it's Pascal case or camel case. I can't really remember. I believe it's camel. So we'll go ahead and use that. So Pydantic offers a way to, well, you can actually do it on serialization or validation. But the one that we're interested in is a upon serialization, we want to translate our snake case to camel case to be, a typical JavaScript syntax type. So we can do that actually with Pydantic in this config dict. So we'll do alias generator is going to be equal to alias generator, and we have to import that. And I think alias generator, here we go. Alias generator is equal to alias generator. And that is going to have some parameters on it. Serialization alias will be to camel. And then we will also pass frozen equal to true here as well. And I think that's all we need to do here in the connection response. And yes. So we can also do this instance of trick here. So if we go through, this should always be an instance of event type. This should always be an instance of, oops, I guess it'd be easier to do it like this. This should always be an instance of this until we add one of these other models here. And then this will also get a instance of treatment here. And then we can also, and I'm just going to point this out, even though this doesn't affect us currently. I think I need to import this, don't I? Okay, this is a different import. So this is from Pydantic alias generators. This doesn't affect us in the way that the code is written currently, but just to point out that it is a thing that you can do. You can use the model config to specify that when there is an enum type or the value of a field, that you use the actual string value for the enum. It's kind of a mouthful to say, so hopefully that makes sense. So in order to do that, we do that with the model config again. So model config is going to be equal to config dict, and then we will do use enum values equal to true, and we will also set this to frozen to true. Like I said, I can't really think of an instance of when or why you would ever need to create this, create these models, and then later on, do some weird transformation on the data and try to use them again. It just doesn't seem right, at least as far as its usage in WebSockets. So let's go ahead and just talk about these other models, these other models here. I think I'm gonna change the names for these two. So let's go ahead and change this name to stats data. And then we are going to call this one stats event payload. Just makes it, I think those are just a little bit clearer of names. So this stats data model is going to just be our interface for this computer class, which is in the stats file here. And it's just, all its fields are just going to be this stats dict. We're just going to essentially create a model to have equivalent fields to this dictionary that the computer class gives us. So we'll do that real quick. I'm actually just going to copy and paste this because it's a lot faster. So no reason to make you just watch me type these out. And like I said, you can get these values from here. So if we go to models again, that looks all good. And then, so the stats event payload is going to be another event. And when this event object is initialized, it's going to create one of these models here, and then fill this model's values with the values that are given to us by the computer class. So to do that, we are going to just specify an event, and we'll do the instance of the event type, and we will specify a data field, which is going to be of the stats data type or stats data model. And that will be equal to, we are going to set a default factory. Yeah, we're going to set a default factory here using field function. And the default factory is going to take a callable, which here we're going to use a lambda function on the stats data model. And we are going to initialize the stats data model by unpacking the values that we get from computer.get stats dict. And that's just going to unpack the method that is on the computer class, which is here. It just returns a dictionary with a string with these object values. I guess this could probably be typed better, but in anyways, that I think should do us for this models file here. Let me just clean this up. So, okay, yeah, the other thing I did too, and this will be in the base structure repo, I added a JavaScript function and some CSS HTML to it'll make it easier to get started with if you can see the nicely formatted response from the WebSocket here. So anytime you want to, or whenever you're ready to get rid of this pop-up here, you can just comment out this display data line, which is 65. I'm gonna leave that here for now. So now we can go to the manager. And anytime we get a disconnect from the, it'll be either, we'll either get an exception because some kind of, the communication between the clients and the server failed, or possibly the client will actually send a disconnect method itself. But at any rate, in either one of those scenarios, we need to handle for that. And the other thing is too, we need to remove that client from our manager's active connections list here, just because they're useless references at this point. And that is pretty easy. We are just going to delete self.activeConnections and then client ID, which we set. Oh, no. Okay. So we're passing this client ID in as a string. So we're going to delete this reference in the dictionary using this client ID. So implementing the handle message here, this is just going to handle any subsequent communication from the client to the server. So here we'll just do a true loop, and we will await a message from, from connection.websocket.receive JSON. And then, and here we just need to check for message.get event is equal to connect and message. Oops, there's a string still. And message dot get client is a server stats client, which is just what I named the type of client that is the front end here. Then we need to start the broadcast loop. So we will await self, caps cell, await self.broadcast to client, string. We're gonna get the WebSocket object using this client ID string. String connection.client, connection.client ID. And this broadcast to client is going to be a loop that just repeatedly sends our data to the front end to be graphed by chart.js. So here we'll do connection of type connection is going to be equal to self.active connections. And since we are getting this client ID string, we can actually get that out. So active connections like get. And actually we're passing a string already, I believe. Yeah. So we can just do client ID. ID, and then if not connection. So if the connection doesn't exist for whatever reason, we're going to return and do nothing. Otherwise, we will, while true, the stats event is going to be equal to the stats event payload, which I did not import yet. Stats events. We need to do stats events data, stats events payload here. So this will be the stats events payload, payload, sorry. And we need to create this object with the event equal to, events equal to event type dot data request, which I don't know if I had us add, which it looks like I didn't. Go to the models here and then go to the event type. We just need to add this data request equal to data request. And that will allow us to use that over here in the manager, data request. And then from here, we'll just go ahead and just print the print JSON. I don't know if I've imported that either. So I'm using rich for this. So storage import JSON. So we'll print the JSON just to see it. Data is going to be equal to stats event model dump, which is going to just dump the Python object model. And then we will await the connection .websocket.send JSON, that's why I typed this up here so we can get this LSP goodness. And then here we are going to send the JSON that is the stats event .model. This is actually going to be sent over the network. So we do model dump JSON. And then we're just going to await. Do I have, what am I doing here for sleep? Okay, cool. So we got the asyncio sleep, await sleep. Just sleep for, we'll just send this data to the client every 1 second. In the get active connections, we are just going to return a list of self. This is just a list representation of the active connections attribute, the keys anyways. So self dot active connections dot keys. Cool. And that should finish up this guy. And then there's some imports that we don't need here. Keep that for now. Get rid of this, get rid of this, get rid of this. I think we're good here. So moving on, you got that's stats. And this is looking good as well. So moving on to main, after this print, we can, I think, actually go ahead and check this frozen equals true parameter that we just defined in the models here. So what do we got here? Wait, this is main line 8. Oh, this one. Okay, going back now. If we go in, going back now, if we go into main now, we should hopefully be able to test this. So we're going to initialize a connection with a client. And here we are getting an exception because the instance is frozen and we are trying to reassign an input value to blah, which is the client ID. So if we take this away, run the server again, you can see that we get a connection with no exception, which is awesome. We got that printed out here. So now all we need to do is invoke the rest of the functionality from the manager class. So in order to do that, after the print here, we're just going to await connection manager dot handle message connection, just in case we get anything from the client. We should, this is where we're actually going to wrap everything in a try. Oops, a try except statement. So we're going to try to do this stuff, and we are going to accept WebSocket disconnect, which I think I deleted the import for, so we'll hopefully get that. Oops, shit. No, I just spelled it wrong, like a dum-dum. And if we get a WebSocket disconnect, then we know that we need to remove that client ID from the connection manager. So we will await connection manager dot disconnect, and then we need to pass in the string representation of the connection. And one of the ways we can get that is the we can do model dump, which is going to give us the Python object, and then as we can call the key client ID to get that. It's just one of the ways. And then here, so this endpoint here, I'll show it to you in a second. This is, we are generating a representation of the JSON object to send. That's an HTTP and API endpoint. We send that to the client, like the client makes an API request to the FastAPI server for this at this endpoint. And the server responds with this data that represents what our objects look like. So hopefully that made sense, but we'll take a look at it here in a second. So here we're just going to return a dict in the data schema, which is just how I defined it, is going to be the stats event payload dot model JSON schema. And we'll take, like I said, we'll take a look at that here in just a moment. And I think that might be it. So let's try to run this. All right, there we go. Yeah, so we got that first try, which is nice. So going over to the JavaScript, we'll go ahead and get rid of this pop-up like I was saying. Move this down. So if we get rid of this, we reconnect, then I guess the best way to do it would be to actually just print it. Actually, no, we can look on the FastAPI endpoint. So if we go up here and we go to docs, we can actually go to this data schema endpoint that we made just now, and we can try it out, execute, and we can look at the string representation of the JSON object that is our stats payload model, which is pretty interesting. It's a little bit verbose. It's not too hard to read. So, you know, we've got the schema, the definitions, the event types could be these. The event type is a string. The stats data object is going to have properties of these, you know, and then these are required fields on that object. Yeah, so it's kind of interesting, pretty cool. But it's really cool that you can generate this structure and then, you know, just host it and pass it off to clients. That way they can expect and utilize some kind of structure for the way that they are going to expect and structure their data. So, which is pretty awesome. But yeah, so that's all the implementation for the you know, FastAPI, WebSockets, and Pydantic. It's pretty cool, pretty simple, pretty easy. But you know, this just with this base structure of a project here, you can do a lot of really cool things. You can make chat room apps, you can make controllers, you can make, you know, a web UI on a tablet that, you know, actuates, you know, via the browser and then does stuff on the server, which could be on your computer, you know, handling audio or doing keyboard macros or, you know, opening programs or whatever. All kind of really cool stuff that you can do with this. So, you know, the sky's kind of the limit, and, you know, your imagination can take you pretty much anywhere with just this basic structure of how to kind of get going to properly use, you know, event-driven data, you know, to drive your application state. So yeah, thanks for sticking around. And I'm going to do a couple other small quick tutorials. I got requested to go over some of the client code, so I'm going to do that here. Not really necessary for anybody to watch to understand, but, you know, somebody asked for it, and I think it probably would be helpful actually. So yeah, thanks for your time.